Hello, I'm Craig Hartman for VFDs.com, and today we're going to talk about how VFDs save energy. I'd like to refer you to the diagram on the screen. This is a diagram that shows a typical fan application, let's say in a commercial building. The bottom line is called the system curve. This represents how much pressure it takes to circulate a certain amount of air through the building. If the building is dark, there's no one there, maybe you don't need any flow, and therefore you don't need any pressure. 0% pressure uses 0% flow. On the other hand, if you need 100% flow, then you're going to need 100% pressure. But the fascinating thing is what that curve looks like in between. You can see that if you only need 50% flow, you only need 25% pressure. If you need 70% flow, you only need 50% pressure. And this is wonderful for giving us energy savings. Let's assume that we need 75% flow, just an example. There are two ways to do this. Number one, we can use dampers. Dampers go in front of the fan, and those dampers basically restrict the airflow. When you put dampers in front of the fan, the pressure goes up a little bit because you're restricting the airflow out of that fan. So at 75% flow, we end up requiring 107% pressure. As you can see, a good percentage of this pressure is dropped across those dampers, and that ends up being wasted pressure. So you can see the amount that is wasted, and you can see the amount that is used. On the other hand, if we use a variable frequency drive, we can simply slow that fan down. We only need 56% pressure to get 75% flow rate, so we slow the fan down to 75% speed, and that will give us just the 56% pressure that we require. No waste. Next of all, let's take a look at a pump application. The pump application works pretty much the same, except for the fact that we have what's called static head. Assume that you have a reservoir in a big tank that's used for water supply to a city. It may take a certain amount of pressure before you get any water flow up into the tank. So in this case, I've just picked a value of 50% as a nice convenient point. We don't get any water flow until we have 50% pressure, and then everything else looks just like the fan curve in the preceding graph. Now in this case, we're using a throttling valve. So we would either use a throttling valve or we would use a variable frequency drive. Let me tell you about a recent fan application, or a compressor application that we did in the eastern part of the United States. It was a biogas situation in which we were taking gas from a landfill, and that gas was then put into a compressor and then used to drive turbines to create electricity. In this case, the compressor was operating at full speed, and they were wasting a great deal of power. We installed a 2,500 horsepower, 4,000 volt variable frequency drive. That drive then was used to slow down the compressor to produce only the amount of pressure that was actually required by the turbines at any given time. In this way, they were able to achieve in excess of $100,000 per year in energy savings. So they actually paid off the drive in energy savings, and this is very common. It's actually very common to see an application where you pay off the cost of the variable frequency drive in less than a year with the energy savings. Be sure to check out our extensive inventory of thousands of variable frequency drives at VFDs.com, or give one of our knowledgeable sales associates a call.